This is Bob Capetta, Professor of Mathematics at College of DuPage, and we're going to look at another lesson in Mathematics for Health Science, this time the line of best fit, sometimes called the regression equation. We want to look at the diabetes data. We want to predict the waist size of a person who weighs 200 pounds. And we can do that because our correlation was fairly large. If you recall in the last video, it was above 0.8. If the correlation is close to 1 or negative 1, it is reasonable for us to do a regression equation to find the line of best fit. If the correlation coefficient is very close to 0, then we do not have a lot of confidence in our prediction, and it's not terribly useful for us to do a line of best fit. But in our case, the correlation is fairly high, so we're going to proceed. Now, to remind you, the equation of a line can be expressed by the form y equals mx plus b. M is the slope and b is the y-intercept. So our goal in this lesson is going to be to find the slope and to find the y-intercept. Once we have that, we will have our line that will enable us to make the prediction. Now, to find the slope, the first thing we're going to look for, we have to use the following formula. The slope is going to be the correlation coefficient r times the standard deviation of the y variables divided by the standard deviation of the x variables. You'll notice that s sub y over s sub x is reminiscent of change in y over change in x that we use to find the slope in the first place. But let's go take a look at our data and identify our standard deviations. We did our correlation in the previous slide. We'll put those together to find the slope of the line of best fit. So this is the data that we looked at in the last video. And we're interested in the correlation between waist size and weight. So we're going to call the weights the x variables. We're going to call the waists the y variables. So I want to get s sub y. S sub y will be the standard deviation of all the y variables, or the waist variables, equals STDEV. Use technology to compute that standard deviation. It'll be very difficult to do by hand. So I will quickly do that. We will let Excel tell us that standard deviation. And it gives us 5.259 as our standard deviation on waist size. For the standard deviation of x, again, equals STDEV. Let's go ahead and compute all the numbers for waist. And we get a standard deviation for weight of 38 pounds, standard deviation of waist size of about 5 inches. We want to find our slope. Our slope is the correlation coefficient, 0.854, times the standard deviation of y, 5.25, divided by the standard deviation of x. So let's do that in this cell, equals the correlation coefficient r, 0.854, times the standard deviation of y, 5.259, awfully close to 5.260, divided by the standard deviation of x. And what does that give us? That gives us 0.117. So that enables us to find the slope of our line of best fit. So that was our formula. The slope was the correlation coefficient r times s sub y divided by s sub x. And our example that we get is that our slope is 0.117. But our next goal is to find the y-intercept b. So we're going to do that by plugging in some numbers. So what next? We find the averages. X bar, the average of all the x's. We find y bar, the average of all the y's. And then we're going to use the equation y equals mx plus b. X bar is going to stand in for x. Y bar is going to stand in for y. We've already computed m, and then we're going to solve that algebraic equation for b. Once we have b, then we have the line of best fit, and we can see what our prediction will indeed be. So we need x bar and y bar, so let's go ahead and define those. X bar will be, y bar will be. So to get x bar, we're going to take the average, equals the average of all of the numbers in the x column. The x column, of course, is weight. And y bar, so the average weight is 182. For y bar, the average waist size will be 37.7, about 38. So we're going to go ahead and use those numbers now to solve for the y-intercept. So our m was 0.117, our average x was 182.63, our average y was 37.70. Now our formula is y equals mx plus b, and our goal is to solve for b. We replace y with y bar 37.70. M we see is 0.117. We replace x with x bar 182.63 plus b. So we have y equals mx plus b. Doing the multiplication, we get 37.70 is 21.39 plus b. Subtracting 21.39 from both sides, we get a y-intercept of 16.31. And now that we have b and m, we know the equation of the line of best fit. So indeed, substituting our value for m and b into y equals mx plus b, we get our prediction equation. Our best prediction is that y, waist size, will be 0.117 times x, weight, plus 16.31. We're going to use this to predict the waist size of a person who weighs 200 pounds. Our prediction equation is here. That is our line of best fit, or our regression line. We want to predict the waist size, the y value, for a person who weighs 200 pounds. 200 pounds is our x value. So 0.117 times 200 plus 16.1, or 39.7, will be our predicted waist size for a person who weighs 200 pounds. So we're going to look at an internet site to visualize this. The one I like is www.alcula.com/calculators/statistics/linear-regression. Now you'll notice down here we need to enter x and y values as numbers only. I'm going to go back to Excel and I'm going to copy those two columns of data that I need. So I've done that, copied the waist column and the weight column. We're going to copy those directly and put them into the data. So submit data, and then the computer will do some analysis for me. So you'll notice they're telling us the sample size, they're telling us the average of the x's, they're telling us the average of the y's, they're telling us the intercept, y-intercept, 16.31, and the slope, 0.117. Unfortunately, they're using different letters. I like to use m for slope and b for intercept. That is indeed more standard. Although in statistics, sometimes those get switched and become a and b. So there is our regression equation. Y is the waist size is 16.3 plus 0.117 times the weight. Now if we look at our data, you'll notice it actually gives us a scatter plot together with the regression equation. You'll notice this is the same scatter plot that we saw before, and you'll see the regression line is a fairly good predictor of how those variables behave. You'll notice the app also allows us to plug in an x value. We wanted to predict a waist size for a person who weighed 200 pounds. If I enter my value for x of 200 and ask it to calculate y, it will give us 39.7. And that will complete this lesson.